So let's look at factoring trinomials where that lead coefficient does not equal 1. Por ejemplo, 2x squared, or something like that.
Sí, muy bien.
Gracias. 2x squared plus 7x plus 6. And what you have to make sure you understand is that we can no longer just look at how do we break down this constant term and add those factors to get the middle term. It doesn't work that way. Remember, you've got to break this down along with the 6. And then combined, you're going to have to end up with 7x. Now, when I break down 2x squared, I can only do 2x and x, right? Now, I'm going to use a pencil here just so that we can erase if we need to. Now, what do you know about your signs?
Positive.
Now, this is what some students will tell me. Oh, if I just put a 1 here and a 6 here. But wait a minute. That gives you x in the middle, but on the outside, what does it give you? Does that give you 7x? No, then you're wrong. All right, so I guess I should put the 6 here, huh? If I put the 6 and the 1 here, does that work out?
What? 6?
Now I can tell you right now, without me actually multiplying this out, that I know this doesn't work. Was there a common factor to begin with in this problem? No, there was no common factor here.
No.
But look what you've created. You've got something you're going to try that has a common factor. This is a contradiction. If there's no common factor here, you are not allowed to have common factors here and here other than, of course, 1. So this is a bad choice. All right. Well, is there another way to break down the 6?
2 and 3.
2 and 3. Now, thinking about what I just said about you can't have common factors together, or at least a contradiction, then what has to go here? 3 would have to go here, and what goes here? Does that work out? Well, let's see. That's 3x there, and that's 4x, and altogether is 7x. What do you guys think? Maybe you remember this a little bit? I know I'm happy. Aren't I always happy? Let's do another example. Yeah, right there.
Yeah. My personal thought.
How about 3x squared minus 10x plus 3? Is there a common factor to take out of everybody here? No. So I expect this guy to factor as 2 binomial factors. How would you break down the 3x squared? 3x and x. What do you know about your signs?
Negative and positive.
You have to multiply to get a positive 3. So have to both be negative.
Oh, okay. The result.
And what are the factors for 3?
1.
3 and 1, but can I put the 3 here?
No.
Because it already has a 3, that'd be a common factor, which is a contradiction. I didn't have a common factor up here. So that means the 3 has to go here. And the 1 goes there. Does that match up? So on the inside here, it gives me a negative 1x. What's on the outside? And altogether, that's negative 10x. What do you guys think? Is it too easy?
You make it complicated.
I make it complicated. How? You ever think that maybe you're the one who makes things complicated?
Of course not me.
Yeah, of course. It's not me, it's you, right?
No, it's not.
See, what I want to show you is that there are a lot of combinations that you just don't even have to try because it leads to a contradiction one way or another. So if I look at 6, unlike the 3, it's not a prime number. So what are the factors for 6? You've got 1 and 6, and you've got 2 and 3. Same thing over here with this term of 6. Now you may not know exactly where to start, so we just pick something and try to go with it. If I try to use x and 6x, let's see what happens. Okay. When I run through my combinations, I've got 1 and 6. Can I put the 6 with the 6? No, so I'd have to put the 6 here and the 1 here, but I know this is not going to work out well for me, because look what I get in the middle. That's going to give me 36 and 1. Will 36 and 1 ever give me 5? No. So no, that guy doesn't make any sense. What about the 2 and the 3? Can I put the 2 here with the 6? I can't put the 2 here because that gives me a common factor that I didn't have up here, right? So that means I have to put the 3 here, right? No, because that again gives me a contradiction. So what we've done quickly here is realize that no matter what combination I use, this 1 and 6 just is not going to cut it. So that doesn't work. Now that doesn't mean that this guy's prime, it just means I need to try another combination. So instead of using x and 6x, maybe I use the 2 and the 3. So 2x and 3x. Now if I come over here and I try to use the 1 and the 6, can I put the 6 with the 2? No. If I put the 6 with the 2, that's a contradiction. It's a common factor, right? So that means the 6 has to go with the 3, right? No, that gives me another contradiction. So that tells me that I can't use 1 and 6 here. So what about the 2 and the 3? What do you know? 3 has to go here and the 2 has to go here. Now, I didn't put my signs here for a reason. I have to multiply to get a negative 6, so I know 1 is positive, 1 is negative. Look on the inside here. You get 9x. What's on the outside? Now, one of these guys will be positive, one will be negative. Okay, which one do you want to be positive or negative?
-9.
The large number needs to be negative to get this guy, so it needs to be negative 9x, positive 4x. So where did the negative 9x come from? 3x times negative 3, and the 4x came from 2x times positive 2.
I mean, 2, I'm sorry.
Questions about that guy?